Welcome to Ask and Learn.
So for this question, we have we have some shell. Try and best of my ability. We have some shell of mass m1, which is hollow, but inside there is a solid sphere with radius r1, and the other sphere has radius r2. And so this has mass m1, this has mass m2. And then we've got to find the force at various locations. So this is point A, this is point B, and this is point C. Now, for part A and part B, this is actually fairly simple, because, or for part B, for part A and B is quite simple because, inside, I'll just write this here, inside a spherical hollow shell, which is like our shell, here on the outside, the grav force equals 0. So for A and B, see, we're inside the spherical shell, so the gravitational force from the shell will be 0. So we only need to focus on the force from the solid sphere. So inside a solid sphere, the gravitational force Fg is equal to gmm over big R cubed, so in this case it will be R1 cubed, times by R, which in this case will be A. And I don't think it gives us any information about mass. Yep, so this will actually be G times M1 times M over R1 cubed times by A. So the standard equation inside a sphere, so inside solid sphere, our gravitational force is gmm over R, big R cubed times by R, where big R is the radius of the sphere and small r is the radius from the center of mass to the point that we're measuring. So as we see, A is small r, R1 is big R, and M1 is the big M, and we're going to leave the other M as small m. So that's the gravitational force for A. For B, this time we're outside the sphere, so our gravitational force is going to be the standard gmm over r squared. This is very standard, so r squared in this case will be B, so this is just g times by m1 times m over b squared. That's very simple. And remember, we have no gravitational effects on the spherical shell, so we don't need to worry about that. And then for part C, we do need to worry about the gravitational force from the shell. So let me just quickly So the gravitational force outside the spherical shell is also gmm over r squared. So for this, it's just going to be, our force of gravity is going to be the force of gravity from the solid shell and the hollow shell. So from the hollow shell, it's from the solid sphere, it's going to be g m1m over c squared, and from the hollow shell, well, we see that c is some distance c away from the center of the sphere, and the center of the sphere is also distance r2 away from the solid shell. So the distance between the solid shell and the in fact, I don't actually think we need to do that. Yeah, I think that's fine. Yeah, so all we need to do here is again just say gm2m over c squared, and that is the answer.